What makes any home insulation work is its ability to trap air. Now what I'm holding is a piece of isonine foam insulation. And what makes it work is just millions of tiny air cells that have the ability to trap air. Now the typical home has over 2,000 linear feet of cracks and gaps. And since over 40% of all the home's energy use in terms of heating and cooling is from air infiltration, it's not only important to insulate the walls, but it's also important to seal off all those cracks and gaps. Now, it's one thing just to put insulation in the wall, but it's important that when you're using insulation that you're able to fill up all the voids around all these pipes and wires. That's one of the beauties about a foam insulation. It has the ability to penetrate in behind all these wires and pipes and do a good job. For example, here you can see daylight coming through here and over here around these pipes, and we're going to be showing you how you take foam insulation and fill all those voids. Now you may be wondering just what is this stuff? Well, let's go outside and take a look at what this stuff is and how it's mixed together. I'm out here at the truck where they have the chemicals and the pumps where they mix all this together. And this is a polyisonine insulation. And here to tell us how all this goes together and how it's made is Sean Rapon, who's the Vice President of Isonine. Got a lot of equipment back in here. How does all this work to make this foam?
Well, isonine is manufactured on site using the equipment we have here in the truck. We have a two-component system, an A and a B, a isocyanate and our proprietary resin in 55-gallon drums. What we do is we put it through a proportioner, heat it up to about approximately 122 degrees, and then send it through heated hoses to a gun. And that's where the two chemicals meet at the tip of a gun and then are sprayed applied into the wall cavity and expands in about 10 seconds to 100 times its volume.
Let's go take a look inside and see how this is installed. So Sean, what's involved in preparing a home for foam insulation?
Well, the first thing the crew does is they come in and they mask off all of the windows just to make sure that none of the spray gets on the glazing. They'll also cover all of the outlets, and again to make sure that they're not filled with foam, and then just clean up any debris on the site and then install.
Now, as these chemicals come together through those two hoses out of the nozzle, it's actually made right there at the spot. Sprays on, expands a lot.
The installers will install it in every other cavity as we go along, and you'll see that it expands out beyond the stud cavity. So any excess material has to be shaved off smooth and flush with the stud cavity, and then they'll come back in and fill every other cavity.
Now, the walls in this home are 2x6 walls. What would the R value be of a 2x6 wall using this foam?
The polyisonine is 3.6 per inch, so we're going to give an R20 in a 6-inch wall.
And what about for a 2x4 wall?
We'll give an R13 in that particular wall assembly.
Now, there's water used in the mixing of this, and does that water leach out into the building materials and cause any problems?
No, actually, the water is the blowing agent, which causes the foam to expand, and it's an exothermic reaction, so all of the water is used up in the process, and there is some heat that's generated, and when they install it you'll actually see the steam come off the foam.
Really?
And that ensures that nothing is left in the product in the wall cavity.
Okay, what about fire? Is there any issues about fire?
Well, the polyisonine is rated as a Class 1 fire product, and that means that it doesn't contribute any fuel to a fire. In actual fact, it will not sustain a flame.
Now, what about attics? You can use this to spray up inside of attics as well?
Yeah, we can spray it right onto the roof deck, and the product will adhere and not delaminate during thermal cycling, or you can spray it right on top of the ceiling.
And when you're spraying it on, you don't have to worry about this dropping off or anything? It holds up pretty well?
No, it will adhere to all the substrate, and you don't have to worry about it coming down immediately or ever.
Now, what about off-gassing? Do we have to be concerned about the chemicals that this releases in the atmosphere? Is it going to have any impact on us?
Well, one of the nice things about using water as our blowing agent is we're able to take out all the CFCs, HCFCs, and volatile organic chemicals that off-gas over time. So in actual fact, once the product is installed in the walls, it's inert and there is no off-gassing.
Oh, that's interesting. It looks like there's a bit of an art on how to apply this to really get it to mold and fit in behind all the pipes and wires.
Well, there is definitely. You don't want to put in too much, nor do you want to put in too little. And what you really want to do is make sure that you get in behind all of the electrical outlet and encapsulate all the pipes. And what we have here is your typical wall section. And what you want to do is ensure that you get behind the copper pipe and behind the electrical outlets, and that will ensure that you have an insulation that has no voids, no cracks, no air infiltration.
Totally fills up the cavity. And then they just come along later and then they saw this off.
It has the consistency of sponge cake, so it saws off quite easily. In actual fact, if this was a real wall cavity, we wouldn't be able to pull this away.
So in summary, you want to install this insulation just like you would any other product in terms of making sure that there are no voids or gaps or cracks in the insulation, making sure that it's not compressed, and making sure that the insulation is in touch with the air barrier both on the exterior and on the inside of the wall. Well, Sean, thanks a lot for being here. It was a great process to see.
My pleasure. Thank you very much.
It's amazing to watch a thin layer of foam expand to fill a cavity several centimeters thick. It even went into the little gaps around the wires and pipes. Of course, that's a good thing because we need to slow the transfer of heat energy from warm to cold areas. Without insulation, buildings would be very expensive to heat and quite uncomfortable. The loss of energy also carries a high environmental cost as our resources are wasted and more pollution is generated. What else can we do to stop the loss of heat energy from our buildings?